Okay, thank you everyone for joining today's TGIB webinar. We are going to talk about the latest project updates around Pulsar and its entire ecosystem. We will get started in a couple of minutes, and let's wait to see people joining the webinar. Okay, so I would get started soon. Okay, so let me present it. Okay, so thank you everyone to coming to the monthly project update. And if you have any questions, feel free to kind of leave your messages in the chat, like use the Q&A panel, and I'm happy to kind of answer the question as long like along in the kind of in the like during I'm talking about a project update. I'm happy to answer all the questions at the end of the webinar. So my name is CJ Guo, and I'm one of the co-founders of StreamNative, and I'm also one of the PMC members of Pulsar in BookKeeper, and have been working with a lot of people in the community and help people adopting and use Pulsar in production. So like before getting started talking about monthly project updates, and I'm going to share a couple of events. And the first one I want to share is the second edition of Pulsar Summit North American is coming back in June. The call for presentation is open, so you can click the sessionized link to go to the CFP page. And if you have been using Pulsar in production, if you want to talk about technology of a specific feature, or dive into like internals of Pulsar, and we like any kind of the topics that related to Pulsar are all welcome. And if you have any troubles on submitting like CFP, feel free to kind of reach out to us, like either over email, mailing list, or Slack channel. And for the Pulsar Summit North American this year, it would be a virtual event. It would entirely hosted in the Hopping platform. And the Hopping platform was used for hosting the Pulsar Summit Asia 2020. So if you have been like signed up on Pulsar Summit Asia 2020, you should be it should be very straightforward for you to check out a new event. And if you want to check for more details about the schedule timeline, feel free to click the link of the we have an announcement blog post detailing all the details about Pulsar Summit North American 2021. And welcome for any submissions, and looking forward to like any awesome presentations around your Pulsar adoptions. The next one is the first ever Pulsar plus Flink Meetup. And this is an event that co-hosted by multiple companies, by Uber, Facebook, StreamNative, and Bavarica. And all the speakers in this meetup would be talking about streaming SQL. Speakers from Uber and Facebook would talk about their in-house system. Some of them are based on Flink, some of them are based on Presto, and how they solve the streaming SQL problems at scale. And the speakers from StreamNative and Bavarica will present the latest integration between Flink and Pulsar, and majorly focus on Flink SQL and how to use Flink SQL to query events within Pulsar. And the meetup is hosted as a 2 series part on March 16th and 17th at 11 a.m. Pacific time. You can join the meetup, the Bay Area Pulsar meetup group and sign up for this event. And this is a pretty exciting event, especially this is a first ever Pulsar and Flink co-meet. This is a meetup that co-hosted by two kind of fast-growing open source community, and we hope use this the event to kind of further promote the cooperation between Pulsar and Flink to the entire streaming ecosystem, streaming community. So so this is kind of the 2 events I want to share that is happening within Pulsar community. And the next one I want to share is that we start a blog series talking about the isolation within Apache Pulsar. And this is the first blog post of a series, and it was done by Peng Hui. Peng Hui is one of the PMC members of Pulsar, and he actually write a bunch of the deep dive like performance tuning and also benchmark blog posts before. And this is a new series from him, dive into the details about the isolation. And I want to kind of use a couple minutes in this meeting to kind of share a bit more about the flexibility of Pulsar in setting up a multi-tenancy or multi-tenant system, and be able to kind of isolate the workloads between different tenants. As everyone know that Pulsar is a multi-layer architecture, and it is comprised of multiple components. Like broker is the serving tier for serving the producers and consumers. Bookies is the storage tier used for storing the messages produced into the cluster. And Bootkeeper is the metadata storage, and as well as the configuration storage for storing all the metadata and configurations for the entire Pulsar cluster. So in order to achieve real world Pulsar isolation, there are kind of a couple of different approach that you can do. The first approach is obviously just have separate Pulsar cluster for each different tenant and different department. So this is a diagram showing that for like you have 2 clusters, and this 2 cluster has a complete setup, complete different setup for both brokers, bookies, and metadata storage. They might share one like global configuration store to kind of sharing some of the namespace policy between different clusters. And using this setup is it can achieve the hardest isolation between different workloads, because for the applications running in cluster A and applications running in cluster B, they don't share any resources. So you can achieve the hardest like isolations between different workloads. And that is what people typically do when they use the like some other messaging system like RabbitMQ, Kafka, or any other messaging systems. They typically set up a per tenant per cluster model, which is very similar as the setup here. And the next one is more about an approach, what we call shared bookkeeper approach. In the other words, is share the storage layer. that means that you can have two different Pulsar clusters, which only running separate Bootkeeper for serving the broker metadata in a set of brokers. But both the cluster A and cluster B would use the same Bootkeeper cluster. The benefits of this is you are able to achieve better like resource usage across different clusters, because you are getting a very large storage pool, and it will get you first you would have very large storage capacity. You can keep data for a much longer duration. You have very large IO bandwidth, because like every cluster can share the Bootkeeper can use the bandwidth there, and you can achieve certain isolate like pretty good hard isolation in terms of the broker resources and as well as the broker bandwidth. So you don't need to worry about the tenant in cluster A is going to use more network bandwidth, which can impact other tenants because they are kind of segregated into two different brokers. The good part is the good thing on this setup is it maximizes the usage of the storage, and it achieves very good efficiency of for storage there. But the bad part here is for your application, you still have two different endpoints. That means for the names for the applications that are running in cluster A, they need to use the cluster A to the service UI of cluster A to talk to the cluster A, and for application in cluster B, they need to use a different URL. And if you want to migrate a namespace from cluster A to cluster B, you still need to use the what's called GL applications to copy the data from cluster A to cluster B, because the broker metadata itself is sitting in two different cluster. Although the kind of the storage layer is shared, but the metadata itself is still kind of in different cluster. So if you want to copy the data, moving the namespace from one cluster to the other cluster, then you still need to do geo-replication to replicate data between clusters. And that is the kind of the second approach. And the last approach is actually, sorry, apologize. The last approach is what we call single Pulsar cluster approach. That means you would have one broker cluster, one Bootkeeper cluster, and one configuration store. And the because you only have one broker cluster, that means you would only have one service URL to interact with. So you don't need to worry about different tenants or different application would have different URL, because that is going to be very hard for management. But you still want certain isolations, like really hard isolation. In Pulsar, there's a concept called namespace isolation policy, and as well as bookie isolation policy. To kind of, I'm not going to dive into kind of the namespace policy, sorry, namespace isolation policy and bookie isolation policy, but just want to give you a very high level. That means you have the ability to configure isolation group in the broker layer, in the bookie layer. So what does an isolation group do is you can group multiple brokers together as an isolation group. In this example, in this diagram is in the broker, we have 9 brokers. So we group the first 3 brokers as group A, the second 3 brokers as group B, and the last 3 as group C. Then when you create a tenant, when you create a namespace, you can assign a isolation group to that namespace, which means for the topics of this namespace, it will be like running on the brokers of that isolation group. So using this mechanism, you can easily kind of segregate the workload for your important tenant or important namespace into a spatial isolation group, because you don't want other tenants or other namespace with like impacting the current namespace. So that is the isolation group in the broker layer. And in the storage layer, it also have a very similar concept, is the bookie isolation group. So you can group multiple bookies into different groups, and you can specify, you can associate with a namespace with a Bootkeeper isolation group. With this isolation group, that means all the data, all the message published to the topic within that namespace would be stored in that group. So you can constrain the usage of the bookies to a certain bookies. So you don't need to worry about that. Some of the workloads might have very large traffic, and it might use all the disk bandwidth. And but isolation group provide you the mechanism for you to kind of reserve certain usage for given certain resources for given tenant. So with this approach, you are able to kind of use one logical Pulsar cluster to serve multiple tenants, and while still achieving very great hard isolation, just as the first approach. And this is what we usually recommend people to use to set up the Pulsar cluster. If you want to use Pulsar in an organization across different departments, but you still want to gain certain like hard resources isolation. And this is just an overview block, but hope that kind of serve a starting point for people to learn more about the flexibility of Pulsar architecture and how you can leverage the flexibility to use different models to deploy your Pulsar cluster to meet your isolation requirements. Penghui is going to have 2 or 3 blog posts follow up to dive into the details on individual kind of setup. And one note I want to point out is both second approach and the third approach, we have seen large deployment. I wouldn't say like you should go one way or the other way. Usually you would use a mixed approach. That means you might have a very large Bootkeeper pool and still have 2 different hardly isolate broker clusters. Within those broker cluster, you can still configure the isolation group. Within the Bookie storage there, you can still configure the Bookie isolation group. So that is the that is the blog that I want to share before I kind of head on the monthly project update. And okay, I am going back here. So first, on the core Pulsar, the core Pulsar project perspective, in the past months, we have kind of we have one release. That one is we release Pulsar Go Client 0.4, and it has fixed a lot of it has a lot of feature enhancement and introduced in this release, as well as fix some of the important bugs. So if you're using Go for developing your Pulsar applications, please check out Go Client 0.4. And in this week, Pulsar 2.71 is already it's already in the voting process. So if you are using 2.7 and you are looking for some of the features that are introducing in 2.71 or like some of the bug fix there, please help the community validate the 2.71 release and give your vote there. So hopefully 271 will be released in next week. Okay, so go back to the Pulsar, like the project progress. So the first thing I want to share, there's one major changes that happening in the Pulsar SQL that is improve existing schema handling to use the Presto decoder. For people who don't know what it's Pulsar SQL, in other ways, Pulsar SQL is a Presto connector that is map Pulsar as a database within Presto. So then you can use Presto SQL to query the data within Pulsar. Before this change, like the Presto integration is using some customization. So we need to write certain integrations on how to serialize, deserialize, like ProBuff, JSON, Avro. But it's very limited because if you want to add more support, like if you want to support new types like row, map, array, then it became really hard. If you want to support more schemas like native ProBuff or even in the future Swift, then you have to kind of rewrite the re-implement the schema handler in order to support native ProBuff or Swift. But Presto already have pretty good integration with all these popular serialization, deserialization framework like Avro, JSON, ProBuff, Swift. So in order to reduce the overhead for us to maintain customized code, there's a PIP called 71 is introducing Presto decoder into the existing Presto integration. So after this PIP, then the Presto connector is able to support the more types like row, map, and array, and also it's able to support the new native ProBuff schema that was introduced in 2.7.0, and that feature will be released in 2.8.0. And since I didn't talk about 2.8.0 in my previous slides, I want to give you an update about 2.8.0. So Pulsar community is using a time-based release schedule. We are releasing a major release every 3 months. The 2.8.0 is scheduled to be released by end of Q1. So 2.8.0 is also coming out in a couple of weeks from now. So this is PIP 71. The next major changes is on the topic policy. As I mentioned, as you probably already know, in 2.7.0, we introduced kind of a new feature called topic policy. That means besides that you can configure policy at the namespace level, starting from 2.7.0, you are able to configure policy in the topic level. Now, if you want to get the final policy of a topic, it will become very tricky because some of the policy is actually coming from the top level policy. Some of the policy is actually coming from the namespace level policy. And some of the configuration is actually a default value that is coming from the broker level configuration. So you have many different sources to form the final policy of a topic. So if you use a Pulsar admin, CLI, or use the RESTful API to query a policy, you might get inconsistent data. When you get a policy from the topic level, it only check the policy in existing for this topic. But if it doesn't existing in the topic level policy, then it would just return none, which is very inconsistent. Which is an inconsistent behavior like across the different command. Then recently, I think there's an effort on providing a consistent way to retrieve the final or the applied policy of a topic. So it basically take all the policies from different sources, like topic policy, namespace policy, and the broker level configuration, and aggregate the policy into the final policy. So when you use a Pulsar command to get the policy, if you specify -- apply, then it would get a final policy. So this would produce a consistent behavior across different commands within a topic policy. And that feature would also be released in 2.8. It's coming soon. The next one is on the client side, that there's a enhancement on improving the listener threading model for key share subscription. So for people who don't know about the listener, is in Pulsar Consumer, you are able to, so a normal application would just call receive or receive async to kind of receive the messages. That is the proactive approach on receive messages, because you need to keep calling receive. But Pulsar Consumer also provide a callback model, is you can register a master listener, and the listener will be triggered each time a message is received by the consumer. That is useful for some people that they are writing the entire application in asynchronous or callback model. They don't need to kind of maintain the logic on calling receive. And so this is the listener. The existing consumer threading model for listener is, for each topic partition, it would use one master listener to dispatch the messages. That means if the consumer is reading from, let's say, 5 partitions, and your listener thread is, let's say, 5 threads, then each thread would get a partition. Then all the master of that partition would use this thread to call the master listener. One of the reasons for that is you need to guarantee ordering for certain subscription, like failover or exclusive. But this approach is not a scalable approach for key share subscription. For example, if I am using key share and I'm reading from one topic, there's no partition. That means the consumer itself can only use one master listener to receive the messages from that topic. So if the processing latency for a given message take much longer time, one master listener is not able to process those callbacks as fast as they can. But you cannot, you have nothing to do at this moment, because if you want to increase the number of the master listener thread, it doesn't help, because each topic is only pinned to one thread, and even you have 10 listener thread, it doesn't help with the consuming from one partition. In order to scale list up is for key share subscription. What it provides is the key-based ordering. In other words, we usually call substream ordering. Then you don't really need to dispatch all the master to one master listener, one listener thread. What you can do is you can dispatch the same key to the same master to the same listener thread. In this way, you can still ensure key-based ordering. So this change is introducing the support for multiple listener thread for key share subscription. So if you're using key share subscription and you are using what's called master listener, you definitely check out this feature. And even you are not using key share subscription, but you are facing the problem of using master listener to process your masters, you can still check out if you can switch your subscription mode from maybe failover to key share and use multiple listener thread to scale up the listener to scale up the processing the masters in mastering listener for key share subscription. So definitely check this feature out once it's released. And in the past months, the Pulsar community has been really focused on improving the observability of the system, because as you know, the Pulsar adoption is growing. More and more people is using Pulsar, and there are certain gaps in terms of debugging, troubleshooting issues in production, and the community has been working actively on adding more stats to improve the operation, improve the visibility and observability of the entire system, and to help troubleshoot any production issues. So the first one is we are exposing two kind of stats. One is pending read, the other one is pending read replay. With that, those are kind of two flags. It's indicating if a consumer is pending on reading data from the bookie pending for reading data from bookies. So that metrics is very helpful for troubleshooting any stuck consumer issues, because there were in the past we have been seeing some of the stuck consumer issues related to some kind of bugs that introduced in the broker side. But it's really hard to kind of for people to easily tell if the consumer is stuck. And a lot of people end up taking the whole heat dump. And when you're taking the whole heat dump, it already kind of takes a lot of energies on copying the heat dump, taking the heat dump, copying the heat dump to a laptop, and then investigate heat dump to understand why the consumer is stuck. And by exposing pending read and pending read replay to the topic stats, it makes the operator much easier to understand what's going on in the broker side. So that is the first one. The second one is about the acknowledgement. So for people, for people just get started with Pulsar, and one thing I want to call out, the current acknowledgement model is the best effort model. That means when the consumer sending acknowledge back to the brokers, the consumer itself doesn't wait for any response coming back from the broker to confirm broker received the acknowledgement. One of the recent for doing that is Pulsar is claimed to be at least once to provide at least once delivery guarantees. So that means when we don't really need to wait until the response coming back from acknowledge perspective, but that would kind of cause a problem which we call lost acknowledgement situation. That is usually when the consumer send the message to the brokers. There's no it might lost in transfer the acknowledgement request to the broker. And even in the broker side, there's periodical flash of in memory state to a cursor ledger in order to persistent acknowledgement. That flash is also done in a batch way. And usually what we have seen is in some of the use cases, due to the lost act situation, you might see the acknowledgement is not being persistent in a cursor ledger, and which would result when there's a broker failure happen, duplicate would be sent. So in order to help troubleshooting the lost act situation, the community has added a bunch of the metrics in the broker side to expose the success rate and error rate on persisting acknowledgement into the cursor ledger, and as well as updating the final state on the Bootkeeper. So these metrics can help in the situation that you are facing lost act issues. And regarding the lost act issues, in 2.8, there's another efforts that we have been work on, is that with introducing, after introduce transactions in Pulsar, we add a response for the acknowledgement, and there's an improvement on the acknowledgement, in the entire acknowledgement flow, to leverage the response of acknowledgement to for the consumer side to retry any lost act situation. So it would help improve the reduce the possibility that you are seeing for the duplicate, even you don't use a transaction semantic in your client. So that is the second enhancement on the stats side. And the third one is about connection being slotted. In Pulsar, there's a lot of, I would say, rate limiting or throttling mechanism, is that it want to ensure any producer or any consumer will not overwhelm the broker. So in the broker side, in the connection level, there's a max pending request based throttling mechanism. So if you send a lot of messages to the broker, but if the broker detect I have, let's say, X number of the messages has outstanding on persisting to the storage there, then the broker would turn the connection to read only. So that means it will stop reading any messages coming from a TCP channel, and this would cause a back pressure going back to the client. This is good for like protecting the system being overwhelmed, but sometimes when it happens, it's really hard to understand if the broker, if some of the connection is being throttled or not. So in this pull request, we kind of introduce two metrics to like measuring like how many connections has been throttled in the broker layer, and what is the global limit. So in this way, you have a better visibility into what's happening in the broker side, if there's any back pressure or throttling applied to the connections. The last one is expose schema ledger. So if you use topic stats internal, use that tool before, then you might already notice that in the topic stats internal, it will give you all the internal information about the list of ledgers of a given topic. But there is a missing piece in the topic stats internal is the schema ledger. For people who don't know like how schema is implemented, I would probably just use one sentence to describe that. Within Pulsar, each topic would be associated with a schema, and Pulsar is using another schema ledger as a log to record any changes on the schema side. So you basically get a schema ledger, and the schema ledger will start the individual schema changes as different versions. And in production, if you're using schema and you want to kind of understand, sometimes you might facing like some of the schema is incompatible, or some of the schema doesn't exist, and you want to looking into the internals of like how the schema has been persistent in the Bootkeeper side. Then right now there's no tools for you to kind of realize that. And in this pull request, we introduce a newer sections in the topic stats internal to expose the schema ledger. So you can use that information to figure out which which ledger is used for storing all the schema versions. And if you want to investigate that schema ledger, you can use Bootkeeper tools to looking into the details of the schema ledger. So that is the last one that I want to show about the stats, visibility or like observability improvement. The next part is about functions. So there are kind of two major updates on the functions. The first one is it's an enhancement on the function context, which is it exposes Pulsar admin interface in the context. I want to just show you how it looks like. Apologize, I should put that in the slides. Oops, yeah. So so in the context, you are able to get the an instance of Pulsar admin, and then you can use the Pulsar admin to access the admin API of Pulsar, and that would kind of unlock a lot of use cases that what you can do in the function side. The first thing is that a very common use cases for people to use functions is very lightweight machine learning, the serving for the machine learning. So you want to kind of keep training, applying your models to so apply changes to a given machining model. So people usually will run the functions, and the function itself would kind of build the machining model and take the inputs from the input topic and apply the changes to the machine learning model. But some of the use cases is if they want to kind of retrain those events, they want to kind of rewind the subscription back to a certain point, so and to replay all the messages. And obviously you can do this, use external tools, but using an external tool is because it's a machine learning training process, you don't know when you should kind of replay those masters. And so ideally, it should be the function itself would have the logic to kind of reset the cursor. And by exposing the Pulsar admin API to the context, the implementation of function can get the Pulsar admin instance and call reset cursor to reset the function subscription back to a certain position, and then the function will start receiving or start replaying all the masters, and in this way you can retrain your model. So this is a very useful feature, and it unblocks a lot of things that you can do by leveraging the admin API. And also this feature will be coming out in 2.8. The last one is more from the resource usage perspective. For people who are already using functions, you probably already know that when you configure function worker, you can give the function resource, the default function resource, like you can configure how many CPUs, how many RAMs, and disk you want to use for a given function, but there's no max limit. That means if your user is writing a very large CPU, very large RAM, then when it tries to schedule the functions, it will figure out that you don't have enough resource to run this function. Especially if you're using Kubernetes, your underlying Kubernetes nodes usually have, like, say, 8 CPU cores. That means for a given function, you cannot use beyond 8 CPU core. If you submit like a request that is asking for 10 cores, then that function will never be scheduled on the in Kubernetes. So so we need to have a mechanism to limit it, what is the max allowed resources in for a given function. So this pull request introduced a section called function instance max resources. And if you are trying to submit a function which would use more resources than the max resource, then your function request will be rejected. This would ensure every function request you try to request for a resource can be satisfied and is able. You wouldn't see any kind of spatial unexpected behavior in the function scheduling part. And this change is also merged recently, and it will also be released part of 2.8. So that is all the changes that is happening in Pulsar in the past months. And we expect those awesome changes will be kind of released soon in 2.8. And I want to use the next kind of 5 to 10 minutes to share a bit the ecosystem update. The first one is I want to share that we recently open source a connector, which is an SQS connector. For SQS is the simple queue service in AWS, and we have been seeing some of the customers used to use SQS before, and they want to migrate from SQS to Pulsar, but they already have some of the application running in SQS, and they want to make sure the data is able to replicate from SQS to Pulsar, so they can migrate their existing application to Pulsar. So the SQS connector is developed for this purpose. And in this repo, it includes 2 connectors. One is source connector, the other one is sync connector. Just as is shown in the diagram, is the source connector is reading the messages from an SQS queue and write data to a Pulsar topic. And for the sync connector, it does in the other direction, read from a Pulsar topic and write to an SQS queue. To configure the SQS connector is very simple. Basically, you just need to provide an AWS endpoint, which is the SQS endpoint. And you need to specify the region where the queue it is, and what is the queue name. Besides that, you depending on how you want to provide your AWS credential, it can be a system environment, or it can be configured in the config through the AWS credential plugins. This is a very simple connector, and if you are using SQS, and if you want to integrate SQS with Pulsar, feel free to check out this SQS connector. The last one is the ProBuff support in Pulsar Flink. So as you know, I probably mentioned a couple of times, is that we introduced native ProBuff schema in Pulsar 2.7.0. And also Flink is working on introducing a new format for ProBuff. That means both Pulsar and Flink is able, Pulsar support the ProBuff schema, and Flink is support to kind of process ProBuff based messages. But the Pulsar Flink connector is lacking the support for the ProBuff schema. So if there's an ongoing progress, like efforts on aiding the native ProBuff support in the Pulsar Flink connector. So if you're using ProBuff in Pulsar, then and as well as using Flink, this feature is something you should watch. And it should be merged soon and will be released probably around next week. And so that is all the kind of updates I want to share today. And just as usual, I want to kind of give a kind of preview on what's coming in the next couple of weeks. Is so we are running monthly project updates every second week, and Pulsar Office Hour every third week, and Intro to Pulsar 101 every fourth week. And so next week at the same time, my coworker Edson, we will do an office hour. So if you have any Pulsar related questions or any issues you hit in the production and you want to talk to us, feel free to sign up our Pulsar office hour, and we'll be there help you solve the problems. And if you're new to Pulsar, we would have Intro to Pulsar 101 the week after. It's a free 1 hour training session to walk you through the fundamentals of Pulsar. And so if you want to learn about Pulsar, feel free to join the Intro to Pulsar 101 webinar. And that's all for today. And I want to see if there's any questions, comment. If there's no questions, I'm happy to give 10 minutes back to everyone. And thank you everyone for attending this webinar. And if you like the format, or if you have any recommendation on how we can improve our format to make it more interactive, feel free to send us an email, ping me on a Slack channel, and we like feedback and to see how we can improve our format in order to provide more useful information for the entire community. And okay, thank you everyone, and hope everyone have a good day. Yeah, thank you. Bye bye.